In this video, we are going to talk about computing the dot and cross products. Let's start with the dot product. We can take the dot product of two vectors a and b by multiplying the magnitude of the two vectors, then multiplying by the cosine of the angle between them. The result of this calculation is a scalar value. Let's define two vectors a and b with their individual components identified in the Cartesian coordinate system. Given these vectors, the question we're going to ask is, what is a dot b? Well, to answer this question, we need some preliminary knowledge. Let's look at any unit vector dotted with itself. Let's consider x, for example. Then x hat dot x hat is x times the cosine of the angle between these vectors. The angle between them is 0. We also note that for unit vectors, the magnitude is 1, so any unit vector dotted with itself is equal to 1. On the other hand, the dot product of orthogonal unit vectors, say x hat and y hat, which are separated by 90 degrees, is equal to 0. As a result, the original question we asked, what is a dot b, is equal to the sum of the x components multiplied together with the y components multiplied together, and also summed with the z components multiplied together. Next, let's discuss the cross product. Imagine we have two vectors which define a plane. Then the result of the cross product is going to point in the direction that is normal to that plane and will have a value which is the multiplication of the magnitudes with the sine of the angle between them. This result is a vector. Now, we have to use the right-hand rule to find out the direction of the normal vector. How this will work is that I will point my hand in the direction of the first vector, curl my fingers in the direction of the second vector, and my thumb points in the direction of the normal vector. For example, for x cross y, I point my hand in the direction of x, curl in the direction of y, and my thumb points in the direction of z, which is the direction of the normal vector. On the other hand, for y cross x, I point my hand in the direction of y, curl in the direction of x, and my thumb points in the direction of negative z, which is the direction of the normal vector in this case. Another fact is that any vector crossed with itself is 0. This is because the angle between the vector and itself is 0, and the sine of 0 is 0. Using the right-hand rule and the Cartesian coordinate system, we can develop the rest of the cross product options. Y hat cross z hat is x hat, z hat cross y hat is negative x hat cross z hat is negative y hat, and z hat cross x hat is y hat, and z hat cross x hat is y hat. This can also be extended to other coordinate systems, but that's not the topic of this video. That's all for now. Thanks for watching. Good luck.